Hi class. I was looking at some of the questions in the Q&A section of our discussion area and thought it might be a good idea to put together a lecture covering the math operators and the precedent. Now, as I pointed out in the discussion area, that table 5-2 is awesome. It has everything listed out in a very easy way to read to see what operators do what with the variables. But for this demonstration, I'm going to go ahead and use something a little more traditional, like the Pythagorean theorem. Now, if you remember from your geometry classes, the Pythagorean theorem is a way of calculating the hypotenuse if we know the other sides of the triangle. So, right, if we have side 1 and side 2, we can take each of those sides, square them, add them together, and then take the square root of that product, and then we have the hypotenuse. So let's write a quick Python program that will do that. And in order to pull that off, we're going to have to use our operators and precedent skills here. Okay, so let me just fire up Python here, and I'm going to go ahead and get my editor going. I'm going to use Vim, but you guys could do this in Notepad or any other text editor tools. Okay, go ahead and got my header values in there. And let's go ahead and just give this a quick little doc string. And we'll just say demo math operators and precedents using, let's see, the Pythagorean theorem. Alright, that's actually, sometimes when I do things like this, I like to kind of document it so that maybe if I come back I know what I'm looking at or why I'm pulling off this formula. So let's go right, let's see, okay, so there's the classic Pythagorean theorem, right? A squared plus b squared equals c squared. Okay, now what I'm going to do here is let's start a variable here, and for this I'm going to do I'm going to be interactive with the user. If you might have noticed in some of Lutz's work there and in the book and his examples, he uses input. Input just a way of telling Python, hey, stop what you're doing as far as executing and ask the user for some input. Okay, so the command for that is input. And then this will be the prompt that we give the user. So we'll say enter side 1. Give a little space there. Okay. And let's do our B. Alright, so input, enter side 2, and a space. Alright, now we need a place to store like our initial square calculation. So I'm going to create a variable here. We'll call it square. We'll say equals a. Now I'm going to use the exponential operator there with the double stars, 2, and then we'll say plus whatever we got input for b, and exponential again, 2. Okay. So what do we have now? We've got this variable here, c square root, is going to have the a variable squared plus the b variable squared loaded into it, or I should say assigned to it. Okay, and then we'll say c equals c square, and I want to take the square root. So there's actually two ways I can do this. The first and easy way is just use the built-in operators of my exponential. So if you think back to math class, right, if we want to take the square root of something, that is just going to be it would be, well, back in school we would wrote that as a fraction, right, like 1/2 up there. So I'm just going to write this as a float of 0.5. And now we'll just output that. So we'll say print I'll open my quote here and hypotenuse. Make sure I spell that right. Yep. And let's do a little string formatting here, right? And then we'll say percent sign and our capital C. Okay, just let's look through that real quick, right? So we're going to take input, and then we're going to load this variable here with that squared value, added squared value, and then we're going to take that square value and take the square root of it to get our C. So I'm just going to go ahead and save that, and let's test it out. So we'll say Python. Okay, enter side 1. All right, side 1, let's say it's 6, and we'll say side 2 is 8, and there's our output, hypotenuse of 10. Now let's do a little test here to see what else happens if I play around with this. What if I said it was 6.5 and this was 8.5? Ooh, it's still 10. What happened there? Well, it was using integer math, right? And with integer math, we're leaving off any of the decimal places, any of the floating numbers there. So let's update our program here quickly so that we can actually work with floating point numbers. Alright, so let's go back in here. And what I need to happen is I need to take this value of input and store it as a float. Two places I can do that in the code. I could go ahead and just say, use my editor properly here. I could say float this variable a. So, cast this a as a float type, because when it comes in, right, it's just going to be a string, and then the string is getting converted to an integer initially. So I could write it like this, and we can save it that way. But I don't like that as much. What I want to do here is actually I'm going to go ahead and just wrap the input as a float, so that way when it comes into my program right away, it's set to what I kind of expect it to be as I'm writing this. So we'll put our float up here, and we'll wrap this whole little function here for input. We'll just wrap it, and I'm going to put my close parentheses down here, and let's go ahead and edit this line as well. Okay, so just a quick point here. Notice how when I'm wrapping a function with inside of a function, I need to make sure my parentheses are in the proper places, and I've got them closed in the proper places. I'm using Vim here, and Vim's got that little handy feature of highlighting the matching closing parentheses. So notice if I mouse over here, it lights up the outer parentheses. Other editors do this if they've got the syntax highlighting, so you can try out the different ones. If you're using like one of the more extensive IDEs like PyCharm, those IDEs also normally have this kind of feature. Okay, so now with that input coming in, it's going to be automatically a float, and then all my other calculations will be floats from there on, right? Because this value here, this 0.5, that's a float, and here we go. That's 2. If I wanted to, I could say make that, force that into being a float. But it won't matter, right? Because once the floats are involved, because of the way we're multiplying or using exponents here, that's going to automatically keep the type as a float. But just to be safe, and when you're programming, I recommend that you use floats when you're working with floats, just because to the visual eye of the programmer or someone else looking at your code, they would know right away that you're trying to make sure that you're working in floats. So let's save that and execute it. So 6.5, 8.5. Oops, sorry. Let's try that again. 6.5 and 8.5. that still didn't work right. Yeah, that still didn't give me the full floating point. I wonder what's going on. I got an idea though. Let's go back in here and take a look. So this is an example of where we've got all the variables are getting set to floats, but check this out. If you notice, I used a %d for my string formatting, and a %d tells Python to format whatever number I'm handing it as an integer. So let's actually just change this to tell it, Python, I'm handing you a number. It's, in this case, it's going to be a float. Go ahead and just do the default string conversion. Right? So we're telling it s, make it a string. It's the equivalent of passing it, let's say print str c, right? We can just say, go ahead and turn that into a string. And what that's going to do is that'll give me all those floating point numbers I'm looking for. So let's save that again. And now let's try 6.5, 8.5. And there we go. We can see a more accurate floating point value returned. Let's go back into our file here. And I mentioned there were two ways to do the square root. Well, we've got that whole math library that we can also import. So let's go ahead and import it and use the math library's square root function. So I'm going to say import math, and we'll go down here and alter this line, and we'll say math and square root, open parentheses. Okay, so here's just kind of the same thing, but using the math library. And let's go ahead and test 6.5, 8.5, and there's our value. It's always a good idea to try a couple different tests. So I'm using floating points. Let's go back and check our decimal. Using integers. Make sure we can still get the same thing. So 6, 8 should get 10. Yep. And we got 10, but notice now that our 10 is a float, and that's because we're outputting it as a string directly converted from a float. All right, let's talk a little bit about precedence here. So if you're reading from the text, let's explain how when Python looks at this line of code, it immediately looks for things that are like exponential, and then after that it looks for things that are multiplication or division operations, and then the last things that it kind of looks at as far as what to do would be addition, subtraction. So when we apply that order of precedence here, it scans this line, says, oh, we've got an exponential function taking place here, so I need to go ahead and do that. And look, there's another one over here, so I'll do that. And then, and only then, does it actually add these. But what if I needed to, I had some other things going on here, like some multiplication or some addition functions that needed to happen before the exponential operators take place. Well, in that case, I would use parentheses to instruct Python on where I wanted it to work first through the order of operations. So right here, what I've done is I've put parentheses around this. Now, I like doing this even when I don't have to, because one, it lets the programmer know right away, as well as Python, how you want the order of operations to take place, so you get what you expect out of the calculation. It's also very handy as your operators in whatever formula you may be putting together, or your algorithm. Having the parentheses there lets everybody know, the other programmers and Python, about how you want this order of operations to take place. and it's just visually helpful as well. So we can go ahead and save that file again, and let's test again. This time let's do 10 and 34, and there's our hypotenuse. Okay, I hope this lecture helps. Post more questions to the Q&A, and I'd be happy to make a few more lectures.